Okay, hello everyone in a new video. So I have reached part 6 of chapters 5 and 6 for grade 8 students, and these are related to mechanical actions, forces, and weight. So number 6, page 117. The title of this exercise is Weight and Mass. Julie wants to find the mass of a ball, but she doesn't have a balance, because we know that from grade 7 that balance is an instrument that measures the mass. So the aim of this exercise is to find the mass of this ball as shown in this document. Fadi suggests that she uses a spring balance so that she suspends the ball from it. So now, before referring to these questions, the spring balance is an instrument that measures the weight, and whenever we determine the weight, we can deduce the mass because they are related to each other via the following formula. Weight is equal to m multiplied by g. So number 6.1. What is the magnitude of weight of the ball that the spring balance reads? So notice that here the needle is indicating 4, and here the scale is given by newtons, so no need to multiply by anything. Then the weight of the ball is equal to 4 newtons. Now in 6.2 they are telling us calculate the mass of the ball, let g is equal to 10 newtons per kilogram. We know that the weight and the mass and g are related via the following formula. And we are interested in determining the mass, then constructing the triangle of this formula. Here because we have multiply, then W will be at the top, M and G at the bottom, and we are interested in determining the value of M. So covering M, then M is given by W divided by G. The value of W that we have determined is 4, and the value of G is given by 10, which means that we are performing this experiment on the surface of the Earth. 4 divided by 10 on the calculator is given by 0.4, and the SI unit of mass is given by kilograms because weight and G are expressed in the SI. Now as for exercise number 7, the title of this exercise is Incorrect Marking. It is marked the net weight 50 grams on a can. Now in 7.1 they are saying that the marking is incorrect. Why? So this is the marking, which means that there's something wrong with this marking. So notice that here we have weight, and they gave me the value of the weight, which is equal to 50 grams. So if you want to say that weight is equal to 50 grams, what is wrong with this is that the quantity and the unit are not in agreement, because we know that 50 grams corresponds for the mass and not the weight. So why the marking is incorrect? Because the quantity and the unit are not in agreement. Now in 7.2 they are telling us to rewrite it correctly. So in this case the correct marking is net mass and here by the net it means the total mass. They are talking about the mass of the can and its content. Now 7.3, calculate the magnitude of the weight of the can on the earth, let G is equal to 10 newtons per kilogram. So we know that weight, mass and gravity are related via the following formula. Now here we have that the mass is given by 50 grams. We know that the SI unit of mass is given by kilograms, and in order to convert from grams to kilograms, we divide by 1000, then 50 divided by 1000, which is equal to 0.05 kilograms. So 0.05 multiplied by 10, then the weight is given by 0.5. Since M and G are expressed in the SI, so the value of W will be expressed in the SI, which is in newtons. So the weight of this can is given by 0.5 in newtons. Now exercise number 9, pages 118 and 119. The title of this exercise is Maximum Weights, Magnitude Supported by a Stage. Students are preparing a show for Mother's Day. At school, the stage can support a maximum weight of 7,000 newtons. So the maximum weight that this stage can withstand is given by 7,000 newtons. The school's principal must ensure that this stage can withstand a group of 30 children who will stand on it at the same time. 9.1. So the number of students that will stand on this stage is given by 30 children. They are telling me that a 6-year-old child has an approximate mass of about 20 kilograms. Calculate the total mass of 30 children. So if each child his mass is given by 20 kilograms, what about 30? So the total mass of these children is given by M is equal to 20 multiplied by 30, which is equal to 600 kilograms. So the total mass of children standing on the stage on this day is given by 600 kilograms. Now in 9.2, calculate the magnitude of weight of the group of 30 children. We know their corresponding mass, and we can determine the weight because the value of G is given to be 10 newtons per kilogram. Then weight is equal to M multiplied by G. No need to construct a triangle because this is the quantity that we are interested in calculating. 600, because mass is expressed in the SI, multiplied by 10, then this is given by 6,000 in newtons. So the weight is given by 6,000 in newtons. Now in 9.3, they are asking us, will the stage support such a weight? Justify. So whether the stage will support such a weight, we need to compare the weight of these children to the maximum weight that the stage can support, knowing that the stage can support a maximum mass, a maximum weight of 7,000. So let me say since, okay, W is equal to 6, since W is equal to 6,000 newtons, which is less than 7,000 newtons, which means weight of the children is less than the maximum weight then yes, the stage will support such a weight. Now in 9.4, They are telling us each student has already prepared a gift to offer to her mother. At the end of the show, the principal put all the gifts in a cardboard box with a center of gravity G. Placed at the base of the stage, the magnitude of the weight of this cardboard box is equal to 120 newtons. In part A, specify the characteristics of the weight vector of the cardboard box. So we are talking about the weight W, and we need to list the point of application, the line of action, the direction, and the magnitude. Now we know that always the first three properties of the weight are fixed, and this is given by the center of gravity G. This is vertical, and this is downward. And notice that I have listed them in the following order, which is given by the builder. Now the magnitude will differ from an object to the other, and here they told me that the weight of this cardboard box is 120 newtons. So now as for 9.5, they are telling me, part B, represent this force on the drawing using the scale 1 centimeter for 60 newtons. And by represent, it means that we need to draw. In order to draw the weight, we need to determine its length. We know its magnitude. Its length can be determined via the connection, which is the scale. Knowing that each 1 centimeter corresponds to 60 newtons. Then what about 120 newtons? Placing it under in newtons. And we need to determine the length. In this case, we need to crisscross. Then 120 multiplied by 1 divided by 60. Then the length of the vector W is given by 2 centimeters. So this, if we need to represent, okay, so this is the point G, and this is the weight W. The length of this vector is 2 centimeters, corresponding to 120 newtons. So that's it for me in this video, guys. In the next part, we'll complete solving exercises on this chapter.